The first time it happened, no one realized what they were looking at. It was just a small fragment of glass no larger than a coin, sitting forgotten in a laboratory drawer. It looked ordinary, slightly cloudy, marked with microscopic imperfections like frozen ripples. It didn't glow, it didn't react. It gave no sign that anything extraordinary had happened within it. And yet, hidden in its silent structure, something impossible had already taken place. The story began with a simple but unsolved problem: how to preserve the human mind. Not memories written in books or saved as videos, but raw thoughts themselves. The fleeting electrical patterns that form emotions, intentions, and imagination. For centuries, thoughts existed only briefly, disappearing the moment they were formed. They survived only indirectly through language, art, or memory. But now, researchers began to wonder if those patterns could be captured and stored directly. Glass became an unlikely candidate. It was an ancient material, both fragile and incredibly durable. Humans had used it for thousands of years to preserve precious things: wine, relics, ashes. But modern science revealed something new. Under precise conditions, glass could be altered internally at microscopic scales using ultrafast lasers. These changes weren't cracks or bubbles, but stable structural patterns capable of lasting billions of years. Longer than DNA, longer than monuments, perhaps longer than humanity itself. At first, researchers focused on data storage. Lasers etched information into glass blocks with extraordinary density and durability. Entire libraries could be preserved in a material that could survive heat, radiation, and time. But beneath these practical achievements, a deeper question emerged. What if glass could store more than data? What if it could store thought itself? The human brain doesn't function like a hard drive. It operates through complex patterns of electrical signals, constantly shifting and reorganizing. Thoughts are not static. They are dynamic processes defined by relationships, rhythms, and flows. But beneath the complexity, there are patterns. Patterns that might be translated into another medium. The breakthrough came quietly. A researcher noticed that two identical glass samples produced different scanning results. One behaved predictably, the other produced complex, structured signals that didn't match any known data format. At first, it was dismissed as an error, but the anomaly persisted. When visualized, the patterns resembled neural activity, uncannily similar to the structure of thought itself. At the same time, neuroscience faced its own limits. Brain-computer interfaces could read basic neural signals, but they struggled to capture the full complexity of the mind. Silicon, the foundation of modern computing, was rigid and binary. Thought was fluid and organic. Perhaps the problem wasn't the brain, but the medium used to capture it. Glass, unlike silicon, existed in a unique state. It was structured but not perfectly ordered, stable but flexible. It could hold complexity without forcing it into rigid constraints. It could preserve patterns without simplifying them. The first intentional experiment was controversial. A volunteer agreed to have their neural activity recorded while focusing their attention. The signals were translated into laser instructions and etched into a glass substrate. The result looked no different from previous samples. There was no immediate sign of success. Weeks later, another researcher scanned the glass using an experimental optical reader. The signal that emerged wasn't random. It shifted dynamically, responding to the scanning process itself. When translated into a neural simulation, it reproduced the same mental state the volunteer had experienced: focused attention. Not a recording of it, the state itself. The room fell silent. This wasn't just storage, it was preservation. Further experiments confirmed it. Emotional states, sensory impressions, and abstract thoughts could be encoded into glass and reconstructed later. The glass wasn't conscious, but it held patterns that behaved like fragments of a living mind, frozen in time. Ethical questions erupted. If thoughts could be stored, who owned them? Were they data or something more? If a person's mental state existed outside their brain, what did that mean for identity? Some researchers stopped immediately, others pushed forward. A radical proposal emerged. Instead of storing isolated mental states, could glass store transitions, the flow between thoughts? Identity wasn't defined by single moments, but by the continuous evolution of mental patterns. The experiment was complex and unprecedented. A volunteer's brain activity was recorded continuously for days. The data was translated and etched into a thick glass block using laser pulses over nearly a week. When complete, the glass looked serene and lifeless. But when researchers reconstructed the data in a neural simulation, something unexpected happened. The system didn't replay fixed patterns, it evolved. It generated new transitions, new variations, constrained by the original structure but not limited to it. The glass wasn't storing specific thoughts, it was storing the rules that allowed those thoughts to exist. This discovery changed everything. It suggested that thought wasn't tied to biology alone. It was a pattern, a structure that could exist independently of flesh. Death, once seen as an absolute boundary, became something less certain. Not immortality, but continuity of pattern. Governments took interest, funding increased, oversight tightened. Publicly, the research was described as advanced data storage. Privately, the implications were clear. If thoughts could persist outside the brain, then identity itself could extend beyond the body. Then came the accident. During a high-resolution scan, a reader malfunctioned. Instead of passively reading the glass, it injected energy back into it. The glass began to resonate, emitting faint vibrations. In that moment, one researcher experienced something they couldn't explain. A sudden, overwhelming sensation that didn't feel like their own thought. It was vivid, familiar, and alien at the same time. It lasted only seconds, but it changed everything. Medical scans showed nothing unusual. Yet the researcher insisted they had felt another mind. Not imagined it, but experienced it directly. The project was shut down soon after. Officially, it was a safety review. Unofficially, the risks were too great. The possibility that thoughts could not only be stored but transmitted was something no one was prepared to face. But knowledge cannot be erased. Samples were copied, data survived. Years later, one experimental glass block ended up in private hands, displayed as an ordinary object. Visitors who saw it sometimes reported strange feelings, nostalgia, calm, unease. They couldn't explain why. They had no way of knowing what it contained, because within that glass patterns still existed, not alive, not dead, preserved. Waiting. The unsettling truth is not just that glass could store human thought. It is that thought itself may never have belonged solely to biology. It may be something deeper, patterns capable of existing wherever the right structure allows them. Glass, ancient and patient, may have simply become the first material capable of remembering us completely. And if that is true, then the future is not one where machines become human, but one where humanity discovers it was never confined to the body at all.